Hello, everyone. My name is Mengmeng Chen. I'm a database researcher from Huawei Innovation Center at Santa Clara. We do have a small team to do database research there. So today I'm going to talk about a project we started a few months ago, which is about distributed query processing with MonetDB. So how do you run a query on a cluster of machines? We first actually set our goals to do a prototyping on a query processing engine using some kind of column-oriented database. Why column-oriented? Oh, it's obvious. It's been proven that it's a powerful tool for a model for the data warehouse. And we want this system to be scalable, both in terms of number of nodes and also to a large amount of data. So I think it's fair to say it's a very ambitious goal even for a relatively larger team. So I think we're just brave enough to dig our own grave. So we start to look at what columnar database we can use, and then eventually we go with MonetDB. The reason is that it's not just an open source column-oriented database. It also has a lot of features, very high quality of code, very good system design, and there are a lot of things that you can use right away, like you can run actually a remote function on another machine, something like you run an RPC function. So we think it's very interesting to see how we can build a system out of it. So this page pretty much summarizes all the things that I want to talk about in this talk, but there are other things going on at the same time. So we first do some work about data partitioning, because we think you cannot scale without partition. So we introduce horizontal partition to MonetDB. And then we start to introduce this data location information into the MonetDB kernel and try to generate distributed plan. To us, it means two things. One is we introduce a couple of parallel execution model for different operators. Another thing is that we try to push as much as possible in operations to the node which contains the data. And it turned out to be a very good strategy for us. And also, we realized that for columnar database, you can do so much things about materialization, not just in the perspective of a single instance, also in the perspective of a distributed environment. So we're also doing things in that part. And we rely on very simple coordination for the query execution. Just talk about a little more about the code generation. So if you look at TP3 queries, and if you do explain and see what MonetDB is doing, you will see usually from a few hundred to a few thousand, several thousand lines of mal code, which is their MonetDB's own assembly language. At the beginning, we have no clue what to do with them. And eventually, we end up wrap up all the functions, all the operations within a function that can be served as a unit of our work for scheduler. So we're doing that. And also, we don't want to throw away any existing optimization that MonetDB already has. So we introduced this code generation phase where we send SQLs to every node and ask MonetDB to do the local optimization. But we rely on the fact that every function we generate has a unique signature. So we don't care about the detail of the implementation, but actually we rely on this interface to do the distributed execution. We did some tests with TPSH benchmark. It's not far from complete, but I think the results are kind of interesting and promising. So we'll keep doing work in that area. And we also tried different scale factor to see how much to where we stop scaling. So we're still also working on that test. Just to summarize what we have done, I think we just started a project in about 2 months, and we have completed most of the stuff we talked about in the previous slides. I think it's very impressive, and also we surprise ourselves in that way. And I think MonetDB is a very good platform for us. It's very robust and good, a lot of features. So we're happy to work with them. And we're doing a lot of things at the same time. So thank you.